Hey everyone, and welcome to the deep dive. Ready to explore something, well, kind of mind-blowing.
I hope so.
Today we're going to dive deep into the very essence of, well, basically everything we're talking about matter.
That's right. We're going to break down matter's key properties and
Yeah.
uncover why it matters to, everyone, not just scientists.
Exactly. And to help us navigate this whole thing, we're going to be pulling some fascinating insights from this chemistry text all about, the properties of matter.
Sounds good to me.
All right. So let's kick things off with the most basic question. What I matter?
In the simplest terms, it's anything that has mass and takes up space.
Okay, so that sounds pretty straightforward, but like when you really think about it, that's kind of a lot, right? I mean, look around you, like everything you see from your phone to the chair you're sitting on to even the air we breathe,
hmm
it's all matter.
Yeah, it really is everything. And all this matter can actually exist in different states, too. Did you know that?
Oh, yeah.
All
You're
right.
talking about solid, liquid, and gas, right?
Yeah.
The classic trio.
Right, exactly.
It's like matter's got a wardrobe change or something for different occasions.
That's one way to put it. So, to help visualize this, think of a neatly stacked brick wall.
Ah,
You know,
right.
that's your solid. Then you've got a flowing river, that's your liquid. And lastly, imagine like the air filling up a balloon that's a gas.
Okay, I can picture all that, but what makes these states so different from each other? Like, what's the science behind it?
Well, it all comes down to how tightly packed the tiny particles within the matter are and how much they're moving around. So in a solid, those particles are super close together, barely any wiggle room at all.
Okay,
And in liquids, they're a bit more spread out so they can flow around each other.
makes sense.
And then in gases, those particles have tons of space. They're just zooming around freely.
Ah, so it's all about the arrangement and the movement of those tiny particles.
You got it.
Fascinating. So we've got the states of matter, but there's obviously more to it than that, right? Like, what about all these characteristics that help us identify and tell the difference between, a rock and a feather?
Ah, you're talking about properties.
Yeah.
And you're right, there's a whole world of them to explore, and we can break them down into two main categories: physical properties and chemical properties.
Okay, so let's unpack this a little bit.
All right.
What are we talking about when we say physical properties?
Okay, well, think of it like describing someone's appearance.
Mm,
Like, you can observe these traits without actually changing who they are fundamentally.
okay.
Like, we know diamond is hard gold, is shiny water flows. All of these qualities are physical properties that help us identify and utilize matter in different ways.
So it's like characteristics we can observe with our senses or measure directly?
Exactly.
Okay, I'm ready for some examples. Hit me with some specific physical properties.
All right, well, let's start with color. Have you ever wondered why we see a banana as yellow?
I can't say I have. I just kind of always accepted that bananas are yellow. But I'm sure there's a more scientific explanation.
There definitely is.
Okay.
And it all comes down to wavelengths of light. So when light hits an object, some wavelengths are absorbed and others are reflected. The wavelengths that are reflected, those are the ones that determine the color that we perceive.
Uh-huh. Okay, so basically a banana is reflecting mostly the wavelengths that we see as yellow.
Exactly.
So every object has its own unique way of interacting with light.
That's right. And that actually leads us to another pretty interesting physical property density. Have you ever wondered why a boat can float even though it can be super heavy, but a rock just sinks straight to the bottom?
Oh yeah, for sure. I always kind of assumed it had something to do with the boat being lighter, even though, like, I know some boats can be massive.
Right. It's not just about weight, though. It's about how much mass is packed into a certain volume.
Okay.
You can kind of think of density as like the compactness of matter.
Okay.
So a rock is way denser than water, which is why it sinks.
Uh-huh.
But a boat is designed to displace enough water to make its overall density less than the water.
Oh, so it's like tricking the water into thinking it's lighter by spreading its weight out over a larger area.
Yeah, that's a great way to think about it. It's all about the relationship between mass and volume.
Okay, this is blowing my mind. What other cool physical properties are out there?
Well, we also have melting and boiling points. These are kind of like matter's temperature thresholds for changing between those states we talked about earlier. Like ice melting into water or water boiling into steam.
Oh, yeah.
Those changes happen at very specific temperatures, which we call the melting and boiling points, and they're different for each substance.
So those dramatic transformations are all thanks to physical properties.
Exactly.
Wow, okay. This is making me look at like everyday objects in a totally different way.
Yeah,
But we can't forget about those chemical properties, right? The ones that describe how matter actually like interacts and changes at a fundamental level.
absolutely. That's where we go beyond simply describing matter to understanding its hidden potential for change.
Mm-hmm.
We're talking about how a substance reacts with others, and sometimes even forms something completely new.
Like baking a cake. You start with all these separate ingredients, and then through a bunch of chemical reactions, you end up with something totally different and delicious.
That's a perfect example.
Okay, so what are some examples of these chemical properties in action?
Okay, well, one that we hear about a lot is flammability. Have you ever wondered why some things are incredibly flammable while others just won't burn at all?
Yeah, it's true. Some things go up in flames with the slightest spark, and others you can't even light them on fire.
Right. And it comes down to how readily a substance reacts with oxygen, which is a key ingredient for combustion. So highly flammable substances have a strong affinity for oxygen. Their chemical structure allows them to react quickly and release a lot of energy in the form of heat and light.
So it's all about their chemical structure and how much they want to bond with oxygen.
Pretty much. Yeah. And then we have reactivity, which is a measure of how readily a substance will engage in chemical reactions with other substances. Some elements, like sodium, are super reactive.
Oh, yeah, like that video of sodium exploding when it touches water.
Exactly. That's a
No.
pretty dramatic example of reactivity.
For sure.
And then lastly, we have toxicity. This one's really important to understand because it directly relates to how a substance can impact living things.
Right. Some substances can be super harmful, even in small amounts, while others are pretty safe.
Exactly. And that's why understanding chemical safety is so crucial.
Absolutely. So we've talked about physical properties, those observable traits and chemical properties, which describe how matter interacts and transforms, but are these properties totally separate, or is there like a connection between them?
That's a great question, and the answer is they're often interconnected. For example, the reactivity of a substance can actually influence how well it dissolves, which is a physical property.
Hmm.
And similarly, changes in physical state like melting or boiling can also affect a substance's chemical behavior.
So it's not just a bunch of separate facts, it's more like this web of interconnected concepts.
Precisely. Everything's related. And understanding these connections is really key to unlocking a deeper understanding of the world around us.
It's amazing to think about all these invisible forces at play that are shaping the properties of everything we see and touch.
It really is.
And you know what? It's making me look at my surroundings in a whole new way. I'm starting to see the everyday in a totally new light.
That's what you like to hear.
Welcome back to our deep dive into the world of matter. Last time we were talking about the basic definition of matter, the different states it can be in, and those key differences between physical and chemical properties.
We even got into some pretty cool examples like how a boat can float even though it's heavier than a rock.
Yeah, that density stuff was pretty mind-blowing. But I'm curious, are these properties of matter like set in stone? Or can they change depending on like the environment or other factors?
That's a great question, and it leads us to a really important concept. The idea that matter's properties can actually be influenced by external factors. So think about water, for example. We know it exists in three states: solid ice, liquid water, and gaseous steam. But what causes it to transition between those states?
Well, temperature plays a big role, right? Like if you heat up ice, it melts into water, and if you heat up water, it boils and turns into steam.
Exactly. Temperature is a key factor in determining the state of matter. But it's not just about the state. Other properties like viscosity and density can also be affected by temperature.
Oh, okay. So like heating up a liquid makes it flow more easily. I know like honey gets much runnier when you warm it up.
That's a perfect example. At room temperature, honey is pretty thick and viscous, but if you warm it up, it becomes much more runny. That's because the heat increases the movement of the honey molecules, making it less resistant to flow.
So temperature can actually affect the arrangement and movement of particles within matter.
Exactly. And it's not just temperature. Pressure also plays a significant role in how matter behaves.
Okay, I can see how pressure might affect gases, like if you squeeze a balloon. But what about solids and liquids? How does pressure affect them?
Well, think about deep-sea creatures. They live under immense pressure, thousands of times greater than what we experience at the surface.
Wow.
And that pressure can actually alter the density and even the boiling points of liquids.
It's like the extreme conditions of the deep sea create a whole different set of rules for how matter behaves.
Exactly. And this highlights a crucial point. The properties of matter aren't absolute. They're influenced by the environment and the forces acting upon them.
This is really making me think about the interconnectedness of everything. It's like this giant web of factors all influencing each other.
And this brings us to another important concept: the relationship between the microscopic and macroscopic worlds.
Okay, I'm intrigued. What do you mean by that?
Well, we've been talking about matter's properties on a level that we can observe and experience in our everyday lives, right?
Yeah.
But these macroscopic properties are actually a direct result of what's happening at the microscopic level,
Mhm.
the interactions between atoms and molecules.
So the invisible world of atoms and molecules is actually shaping the properties of the objects we see and touch every day.
Precisely. For example, the hardness of a diamond is due to the incredibly strong bonds between carbon atoms in its crystal structure. And the reason metals are such good conductors of electricity is because of the way their electrons are shared and can move freely within the material.
It's like zooming in on a seemingly simple object and discovering a whole universe of complexity at the atomic level. It makes you realize there's so much more to matter than meets the eye.
Exactly. And speaking of surprising discoveries, did you know that a teaspoonful of neutron star matter would weigh billions of tons?
Billions of tons
Yeah,
in a teaspoon.
that's insane.
It sounds like the more we learn about matter, the more we realize how much we still don't know.
Absolutely. And that's what makes it so fascinating. The study of matter is a journey of constant exploration and discovery.
For sure. And it's a journey that has the potential to revolutionize our understanding of the universe and lead to some incredible technological advancements.
You got it. So are you ready to hear about some of those advancements?
Oh, yeah, definitely. Where is this knowledge about matter taking us in the future?
Well, one area that's absolutely exploding right now is nanotechnology.
Okay.
Remember how we were talking before about those strange quantum effects that happen at the nanoscale?
Yeah, like quantum tunneling, where a particle can pass through a barrier that it shouldn't be able to.
Exactly. Well, scientists are figuring out how to actually harness those effects to create materials with entirely new properties.
So we're not just observing those quantum quirks anymore, we're actually controlling them.
That's right. Imagine materials that are stronger than steel, but lighter than a feather, or surfaces that repel water and dirt completely. This isn't science fiction anymore.
That's incredible. What kind of real-world applications are we talking about?
The possibilities are pretty much endless. Imagine ultra-efficient solar panels that capture almost all of the sun's energy, or super-fast computer chips that revolutionize computing power, or even targeted drug delivery systems that can attack diseases at the cellular level.
It sounds like nanotechnology could completely transform so many aspects of our lives.
It really could.
Are there any other areas where our understanding of matter is leading to big breakthroughs?
Absolutely. Scientists are also exploring ways to manipulate matter at the atomic level to create entirely new forms of energy.
Wow, like nuclear fusion. I've heard that's like the holy grail of clean energy, but it's incredibly difficult to achieve.
It is incredibly challenging, but the potential payoff is huge. Fusion involves combining atomic nuclei to release massive amounts of energy similar to what happens in the sun. If we can figure out how to make it work, it could provide a nearly limitless source of clean energy.
It's amazing to think that by understanding and manipulating the fundamental properties of matter, we could potentially solve some of the world's biggest challenges.
It really is inspiring. But it's not just about solving problems. The study of matter also have the potential to expand our understanding of the universe in some really profound ways.
Okay, I'm ready to get cosmic. What kind of big questions are we tackling?
One of the biggest mysteries out there is the nature of dark matter and dark energy. These invisible forces make up the vast majority of the universe, but we still have very little idea what they actually are.
So even though we can't see or directly interact with dark matter and dark energy, their presence is influencing the behavior of the universe on a grand scale.
Exactly. And by studying the subtle gravitational effects of these mysterious substances, scientists are trying to piece together their properties and ultimately unravel the secrets of the cosmos.
It's mind-boggling to think that there's so much more out there that we're only beginning to understand. This has been an incredible journey so far.
I agree.
We've gone from the basic definition of matter to exploring cutting-edge research that's pushing the boundaries of human knowledge. But before we wrap up, I want to touch upon one more aspect of matter. The idea that even though we have all these fundamental properties, sometimes matter can behave in some really unexpected ways.
You're right. And this is especially true at the nanoscale, where quantum effects can really start to dominate. For example, there's a phenomenon called superfluidity, where certain liquids at extremely low temperatures can flow without any resistance.
Wait, flow without any resistance, so it's like perpetual motion.
It's not quite perpetual motion, but it's pretty close.
Yeah.
And it all comes down to the strange rules of quantum mechanics that govern the behavior of matter at those tiny scales.
It seems like the more we delve into the world of matter, the more we discover how much more there is to learn. This has been a truly mind-expanding experience.
I agree, and there's still so much more to explore, but I think we're actually out of time for this segment.
And we're back for the final part of our deep dive into the world of matter.
It's been quite a journey, hasn't it? From the basics of what matter even is to, the strange and exciting world of quantum effects and nanotechnology.
Yeah, I mean, who would have thought that something as simple as density could explain why a boat floats? Or that those bizarre quantum phenomena even exist?
Right. And we've only just scratched the surface. But for this last part, I want to shift our focus a bit and talk about what all this knowledge about matter means for the future.
Okay, I like where this is going.
Like, how are scientists pushing the boundaries of what we know? And what kind of world could these discoveries create? Big picture stuff.
Yeah, let's get into it. What kind of cutting-edge research is happening right now in the world of matter?
Well, one area that's really exciting is the development of metamaterials.
Metamaterials. Okay, I've never heard of those.
Yeah, so these are basically engineered materials with properties that you just don't find in nature.
Like what? Give me an example.
Okay, imagine a material that can bend light in ways we've never seen before.
Yeah.
Like to the point where it could make objects invisible.
Wait, hold on. Invisibility cloaks. Are we talking like Harry Potter stuff here?
It's not magic, it's science.
Yeah.
By carefully designing the structure of these metamaterials at the nanoscale, scientists can actually manipulate how they interact with electromagnetic waves like light.
So we're not just discovering new properties of matter, we're actually creating them.
Exactly. And the potential applications are mind-blowing. I mean, imagine super lenses that can see things at the atomic level, or soundproofing materials that can completely block out noise pollution.
Wow. That's incredible. It sounds like we're entering a whole new era of material science where the only limit is our imagination.
I think you're right.
Okay, so metamaterials, that's one thing, but what other mind-blowing advancements are on the horizon?
Well, and another area that's rapidly evolving is quantum computing. Have you heard of that?
Yeah, I've heard the term, but I'll be honest, I don't really understand how it works.
Yeah, it's pretty complex stuff. But basically, instead of using bits, which can be either a 0 or the quantum computers, use qubits, which can be both 0 and 1 at the same time.
Whoa, wait, what? How is that even possible?
It all comes down to the weirdness of quantum mechanics. But basically, this means that quantum computers can perform multiple calculations simultaneously, making them exponentially faster than regular computers for certain types of problems.
So it's like having a computer that can explore like multiple possibilities at once.
Exactly.
That's insane. What kind of impact could that have on our world?
The potential is huge.
Yeah.
I mean, quantum computers could revolutionize fields like drug discovery materials, science, artificial intelligence. We could design new medicines, create more efficient energy sources, and even crack some of the most complex codes in existence.
It sounds like we're on the verge of a technological revolution, all thanks to our deeper understanding of matter.
I think so.
Yeah.
But it's important to remember that with any powerful technology, there's always the potential for misuse. We need to be careful and thoughtful about how we develop and use these advancements.
That's a really good point. It's not enough to just chase scientific progress. We need to consider the ethical implications as well.
Absolutely.
Well, this has been an absolutely incredible deep dive. It's left me with a sense of awe and wonder about the world around us.
That's great to hear.
The study of matter, it's not just about, understanding the building blocks of the universe. It's about unlocking the potential for a brighter future.
Couldn't have said it better myself.
And the journey's far from over. There are still so many mysteries out there waiting to be unraveled.
Exactly.
Who knows what incredible discoveries lie ahead?
Maybe one of our listeners will be the one to make the next groundbreaking breakthrough.
That's a great point. So to all our listeners out there, stay curious, keep exploring, and never stop asking questions about the amazing world of matter. And that's a wrap on this deep dive into the world of matter. Thanks for joining us, and until next time, keep those minds curious and those imaginations fired up.
You've been listening to the Learning Podcast, a production of Metanesta. Remember, learning is a journey, one step, one insight, one skill at a time. We'll see you next time. Keep learning, stay curious, and as always, be awesome.